not just for light, they also include the matter wave. Hence, we have the mass of the electron here. And here are the definitions. So B, D, E, and H, which is H, E, B, and D. They are your standard Maxwell's equations. B over H is mu naught for empty free space, and D over E is permittivity of empty free space. We have coefficient of velocity and acceleration, which is dv dg or dv dA. We have in this box, you multiply going to the right and up. Sorry, to the right and down. You divide if you're going backwards or upwards. So if you take the velocity of the electron, qv, which is c0 over lambda e, where lambda e is 1 over the fine structure constant, often denoted by lowercase alpha. If you now multiply this by 10 to the minus 23 over lambda b, where lambda b is this value, 136 point blah, you end up with the charge of the electron. So if you plug in the speed of light in a vacuum, 10 to the minus 23, and then divide that by lambda e times lambda b, get the charge of the electron. The mem resistance for empty free space is the charge to mass ratio, and that is the impedance of empty free space, which is the square root of this equation, and that is Z0 over H times 10 to the minus 47 will indeed give you the mass of the electron. So does the acceleration of the electron. Now the velocity of the electron is E over B, which is C0 over the fine structure constant in reciprocal form. We have exactly the same here, speed of light, but over the fine structure acceleration, as I call it, which is 1 over lambda b. That, when it's multiplied by 10 to the minus 23 over lambda e, is the equivalent to this one, 10 over lambda b, which will give you the charge of the electron. If you then multiply it by m0, gives you the mass. No different to the charge of the electron multiplied by m0 gives you the mass of the electron. Here we have the impedance of empty free space over the Planck's constant, and we're going to multiply that by 10 to the minus 47. What else do we have here? Obviously, we have 1 over the speed of light, fine structure constant. This is 1 over qv, which will be b over e. Hence, you've got e over b. And again, z0 over lambda e. We'll link these two. And these are the actual physical values. So h has the speed of light over Planck's constant multiplied by lambda e over lambda b, which is this thing here. So that you can replace that with r0, and you have 10 to the minus 34, which is standard to all of these. You'll of course recognize that 10 to the minus 34 undoes Planck's constant, which is 6 point whatever it is times 10 to the minus 34. We have z0 over h times speed of light over lambda b, and we have 10 to the minus 34 over Planck's constant and lambda b. Now lambda b is this little number here, 13.65 blah, which is used in here to create the acceleration. So just as meters per second multiplied by seconds gives you meters with length and mass, where you have the gravitational constant g over c squared as the coefficient for linking that in mem resistance, we have the same here. We have meters per second squared. And so obviously, if this is time for special relativity, then we have here time for gravitational time dilation, which is, I think, 2gm over r squared, isn't it? So you can plug in your lengths to create this mass. This is the mass that that J.J. Thomson used in his experiment to find the charge to mass ratio. In here, this is all about empty free space. Outside is to do with matter waves as well, but inside is to do with empty free space. Here's hc. That's a very common value in de Broglie waves, etc. Here we have what we have is space-time as a core sample that is wrapped up into a loop, and then remember that as the frequency through here goes very, very, very high, this impedance, j omega mu naught, becomes very, very high indeed, and it's almost as if that's not existing there at all. But remember, you have capacitance between the coils, which is represented by this, and those capacitances at very high frequencies become 1 over j omega c. They become short circuit. So this actually does give you a kind of a bump where you have a maximum energy transfer where those two are equal. Below the frequency and above a very high frequency, then they might as well not be there. And that is the standard transmission line equation, R plus j omega b over h, which is mu naught, multiplied by 1 over m, because we need the reciprocal of that, because we're looking for the standard wave ratio, and the j omega d over e. If you want to know how the transmission line equation works, then there's plenty of that on the internet to go and find out. I think all these other values are pretty self-explanatory. What I find interesting about this particular one here is that this shows that there is a gravitational well at the proton for the electron to have a mass. So this is all about the Higgs field being generated. That is all about electromagnetics coming across. Thank you for listening.